Hey Lancers! Here we are, 11.7, and this is the last section of the chapter. Woohoo! And in this chapter, we are going to be exploring areas and volumes of similar solids. Now, going back to our information from before, way back when we talked about what similar means, similar simply means with our two-dimensional shapes, the same shape except different sizes. And the same thing goes for solids. So with solids, they're the exact same shape, but different sizes. Same angles, same everything, just the sizes are different. So we're going to take a look at problem number 1. And in this one, we're asked simply to identify if the two shapes are similar, and then also identify what the scale factor is if they are similar. So let's take a look at the first one. All we're going to do is we're going to compare the corresponding sides. So as you can see as I'm writing, we got 3 over 6, and then we go to the next set, 3 over 6, and the next set, 2 over 4. And if we simplify those fractions, you will see that they are all the same. Therefore, we have similar solids. Okay? Those are linear measurements, by the way. And so, as a result, we get our ratio of A to B, which I'll talk about show you in a second. But since the linear measurements scale down to 1 over 2, that actually becomes a scale factor as well. Going back to what we've learned before, we've learned that when we compare linear measurements, that's simply a ratio of A to B, and that also represents the scale factor. But if we're talking about area, then that becomes A squared to B squared. So when we're talking about ratios of one particular side, let's say, to another. And then we're just comparing volume, as you probably guessed, it's A cubed to B cubed. Moving on to this next example, you can see that as we compare corresponding sides and write ratios, they all don't simplify down into the same fraction. Therefore, it's not similar. Okay. So just as I talked about earlier, this theorem, 1112, simply identifies how those different types of measurements correlate with one another. So if we're talking about scale factor or linear measurements, it's an A to B factor. If we're comparing areas, it's an A squared to B squared. And if we're talking about ratios, then it's A cubed to B cubed. And I also apologize, this is another voiceover, and this is actually quite a long video as well. But anywho, moving on. Taking a look at these two solids, we are given the volume, and we are supposed to find the scale factor for each of these. So notice we have the smaller one at a volume of 729 centimeters cubed, and the bigger one has a volume of 1,331 centimeters cubed. And all we're going to do, actually, is get the cubed root of each of those numbers. We want to get that A cubed to B cubed down to A to B, right? Or A over B. So we're going to get the square root of 729. That'll get down to 9. I'm sorry, cube root of 729. And the cube root of 1331, that gets us 11. And so we get our scale factor, 9 over 11. But if you guys are interested in what cubed root means, think about square root first of all. You have the square root of 4 equaling 2, which is 2 times 2 gets us 4. Cube root of 8, meaning what number times itself 3 times, is going to get us 8. So if you're wondering how to get the cube root of a number on your calculator, simply take that number and raise it to the power of 1/3. Or if you could find that cube root sign in your calculator, just hit that button first, throw the 729 under that, and you'll have your answer. Okay, so moving on to our last and final problem. Notice in this problem, it's saying the lateral area of the two similar paint cans are given. So we have 1019 and 425. We're also given the volume of the smaller can, 1157. And we are supposed to find the volume of the big can. So just notice how I'm writing them. I'm identifying or labeling the cans. And also notice that we're missing the volume of the big can, which is what we're trying to find. So what we have here, we have the lateral area, and I'm just saying lateral area of the big can, and that is the lateral area of the small can. I'm going to write those numbers in. 1019 over 425. And if you remember, when we're comparing areas, that's in the form of a squared over b squared. But we want to take those numbers and convert them into a over b. So all you're going to do is simply take each of those numbers, so the 1019, and get the square root of that. 425, get the square root of that. And you'll get these nice little decimal numbers here. 31.92 over 20.62. And now we have our scale factor as well. Okay, so we have our form A over B. Remember, we're working in volume. So we're basically going to take those numbers and cube them in the next step. So notice how I have A cubed over B cubed. And as you can see the work, I'm just going to cube these guys. Now you can leave them in cubed form, or you can hold those values in your calculator. But just for this video, or if you're doing work at home, you can just simply write out these big gigantic numbers, which I'm going to give you right here. Yeah, so notice I made a little boo-boo there, but I'm fixing it now. So 31.92 cubed is this giant number, 32,522, and that's over 8,767. But now we have our ratios of A cubed, B cubed. And we're going to use that ratio now to solve for our answer. Right? Remember, the answer or the question is, what is the volume of the big can? So we're simply going to just set up our ratio to solve for the volume of the big can. So notice it's VB, right, volume of the big can, over 1157, which is the given volume of the small can. I'm going to take my ratio from up above. We do a little calculator magic, and that should get us our answer. Volume equals 4,292. And depending on your calculator work and how good it was, it'll be a little bit different than mine, but that answer is perfect. And if you're right around there, that'll be perfect as well. And don't forget those units. Awesome, guys. All right, I'll see you guys later.